we understand already, we understood about the nature of the material and resistance. So here resistance depends on the nature of the material, like made up of copper or made up of iron, made up of aluminum, made up of silver or made up of tungsten, everything. So what material you are using in making of that particular wire, depending on it, the resistance of the material changes. If you maintain rest of the things all constant, but that material nature affects the resistance. So that you need to control here. The next here, we are trying to understand the conductor. Does it affect the resistance value or not? So you are using the same circuit here, right? Same circuit here, just left with the gap P and Q, right? So here I am understanding about the importance of length in this resistance, how it affects, right? So for this observation, I need to maintain a cross-sectional area, then nature, right? Only one substance or one type of material wire. The next, temperature. I need to maintain constant, right? I am changing only the length. Suppose if I select a copper wire, right? Only one type of string you can use. From that only, you can cut this copper wire into 10 centimeters length, 15 centimeters length, 20 centimeters length, and so on. As many as, right? Maximum 3 enough to give generalization, to conclude, right? So here I can select a copper wire, right? Only one piece of wire. So that piece of wire is cut into 10 centimeters to 15 centimeters to 20 centimeters, different lengths, right? Then connecting the gap, this PQ left in the figure number 14, that only here drawn here, right? So here I am connecting that wire here in between P and Q, right? With the string of wire having suppose 10 centimeters length, having 10 centimeters length. Then what to do? Switch on, then observe the ammeter value, current value, right? Or set this multimeter into ohmmeter, then you can read the resistance value, no problem, right? So anything will give you idea about resistance only. So here measure the resistance. So resistance of the 10 centimeters length wire. Then next what to do? Just replace this 10 centimeters wire by using 15 centimeters length wire. Then what to do? Switch on, then observe the ammeter or ohmmeter, anything you can set up. So here 15 centimeters length wire resistance you can measure. Next what to do? Just you need to replace this 15 centimeters wire by using here 20 centimeters length copper wire. Then measure the resistance. So I got three values here. I got three values, right? They are giving you same or different, that you need to compare. So you will get X, Y, Z. That means what I am trying to say here, you will get the different values. You will get the different values. Then compare this X, Y, Z, which is less, which is more. So X is less than Y, Y is less than Z. Then what happened here? The resistance of the wire increased. The resistance of the wire increased with increase in length. With increase in length. So resistance depending on the length of the wire. Then in what way they are here related one to the other? The resistance of the material increasing with increase in the length. So both are in directly proportional, right? So resistance is directly proportional to the length of the conductor, that we are concluded, right? So here cross-sectional area is maintained constant, nature of the material maintained constant, temperature maintained constant. But we noticed here the resistance depending on the length of the conductor. The resistance is depending on the length of the conductor, right? So this we finally concluded in the activity number 4. Are you clear about this activity? Have you got idea? Have you got idea? Put your quick reaction. Yes. Right. So now we'll go for another activity here. That is sectional area affecting the resistance of the conductor. So here, just I am verifying the resistance based on the area. So I am changing what? Changing the cross-sectional area of the material, right? Then rest of them constant. So resistance measuring. What about resistance with change in the cross-sectional area? Resistance increases or decreases or remains same, that you need to conclude. So here I am maintaining temperature constant, length constant. Next, nature, that means wire material constant. So here I am selecting a copper wire, suppose, right? Copper wire. That length I am going to fix as 10 centimeters here. Then temperature, you need not to change anything. That voltage you are maintaining constant. Voltage you are maintaining constant, and weather condition time, right? You need to maintain constant. Then automatically your temperature will be set up to the constant value, right? On the same day, right? Within the duration, that 1 hour. Within that, maximum temperature will not change. That 1 or 2 degrees Celsius temperature will not affect you more. Okay, so that is negligible. Okay, here we maintained these things, right? We maintain these things. Then here, what I am changing here, cross-sectional area. So taking the 10 centimeters wire only made up of copper, but different thickness wire pieces you need to collect. Different thickness wire pieces, right? That you need to collect. Then automatically your problem will be solved. Okay. So you are having the different cross-sectional areas now. Then what to do? Just use the circuit you are made as shown in the figure number 14. Just replace the gap PQ with the wire pieces what you are collected, 10 centimeter copper wire pieces having the different thicknesses. So first less thickness wire, then slowly increase the thickness of the wire, right? Every time you need to measure the value of current or the resistance, current or the resistance. Then automatically you will decide that the resistance affected by the cross-sectional area or not. So here what you are going to conclude. So area of the wire increased, the cross-sectional area of the wire increased. Then what happened? That simply resistance will be decreased, right? So resistance will be decreased. So here simply increase in the cross-sectional area, resistance is going to be decreased. So in what way they related here? So resistance is inversely proportional to the cross-sectional area. This we are concluding, right? So resistance of the wire, right, having the same length, different thickness, what we noticed, decreased with increase in the thickness, right? So thick wire only offering the lower resistance, thin wire offers more resistance. Okay, so here that is the relation between the cross-sectional area and the resistance. So resistance is inversely proportional to the thickness of the wire. This we concluded from the activity number 5. So here I am just giving importance to the length and cross-sectional area. So here resistance increased with increase in the length of the wire. Then resistance decreased with increase in the thickness of the wire. So here, rest of the things are same here. Water temperature and the material. Temperature and the material nature are same. So in this, what I observed, so this I observed what I written here, R is proportional to L and R is proportional to 1 by A. So simply here I am trying to write a common relation between them. So R is directly proportional to L and inversely proportional to the cross sectional area. So here R is proportional to L by A. So if I remove this proportionality constant, what I am able to write here, R into A by L is equals to constant. R into L by A is equals to constant. So simply here, what the constant is, proportionality constant. I removed the proportionality and I introduced a constant. That constant is called the proportionality constant. What that tells us? The constant tells us here simply about a new thing that is called here resistivity. You are able to find out one more material nature, that is resistivity. Right? Based on what? These factors, length and cross-sectional area and particular resistance of the material will give you resistivity. So that resistivity here denoted by the symbol called rho. Greek letter, we can use this one, rho. Read as rho or HO. Read as rho. So this rho is telling about us simply here specific resistivity. Specific resistivity. Right? So here I got rho is equals to RA by L. So what are the units of resistivity here? Resistivity units are here in SI system. R takes ohms, cross-sectional area takes units, meter square, and length takes meter. So square and meter cancel. So what are remained here? Ohm meter. So these are the units of resistivity. Ohm meter. Units of resistivity are what? Ohm meters. Right? So here I got units of resistivity. Then here, if you take a reciprocal of the resistivity, that will give you one more quantity called conductivity. Right? Conductivity. What is conductivity here? Reciprocal of the resistivity. 1 by rho. So conductivity is given by the symbol here, sigma. Denoted by the letter Greek symbol sigma here. So sigma equal to what? We can write the formula here, 1 by rho. So 1 by RA by L. So denominator is a fraction. That will be written as reciprocal. So L by RA. 1 L by RA. So here units of conductivity. Units of conductivity. Meter by ohm meter square. Substituting that L meters, R ohms, and cross-sectional area meter square. So cancel. What remained? Ohm meter. 1 by ohm meter. So here if you take this into the numerator, that can be read as here Siemens. Right? Siemens. Okay. So we can write as here mho per meter or Siemens per meter. Right? Units of conductivity are Siemens per meter or mho meter. Sometimes you may given like this also. So power inverse taken into the numerator, power will be written as minus negative power. Right? Law of exponents. So this is about conductivity. So here, based on the resistance value, suppose it has more resistance high, then what about its resistivity? Can anybody answer me? If resistance is more, what about resistivity? Resistivity increases or decreases if resistance of the material increases. Tell me, especially 10th class students. Richaran, Abhinay, Rohit, Vikrant. Here the formula is rho is equals to RA by L. Then here rest of the things are taken to be here constant. That means A and L are constant. That means you are able to write a relation between rho and R. They are directly proportional. Have you got idea? Use your quick reaction. How I am written that relation. I am maintaining the cross-sectional area and length are constant. Constant means nothing. What you are maintaining fixed values in their physical properties. Maybe the mass, maybe the density, maybe the length, maybe the cross-sectional area. Sorry, maybe the volume. They are only constant here. Nothing constant means just what you are fixing the values of physical properties. They are only taken to be constant here, right? Have you got idea? What is meaning of constant here? Yes. So this is, I made a relation between resistivity and resistance. So resistance increases, resistivity of the material increases, right? So this is the relation. Once the resistivity increases, that means resistance is more, or resistance is more, resistivity increases. Resistance decreases, resistivity decreases. Same way. That is only directly proportional. Have you got idea clearly about this resistivity and resistance relation? Use your quick reaction. Resistivity and resistance relation. How they are related. Right? So got an idea, okay. So now one more we are trying to understand here. That is resistivity conductivity relation. Conductivity resistance relation. Can anybody give me the relation between resistivity and conductivity? If you don't know, I'll proceed. Okay. So here nothing, simple. Here resistivity and conductivity relation is what? Conductivity is equal to reciprocal of resistivity. So how they are related? The conductivity is inversely proportional to 1 by rho. Conductivity is inversely proportional to the resistivity. Resistivity is directly proportional to the resistance. So I am able to give a relation between resistance and the conductivity in the same way. Reciprocal. Conductivity is inversely proportional to the resistance, right? So once if the resistance of the material increased, what about the conductivity? Resistance increases, conductivity decreases. Resistance decreases, conductivity increases. Resistance increases, resistivity also increases. Resistance decreases, resistivity also decreases. See here. Have you got clear picture about this one? User quick reaction. Conductivity, resistance relation, resistance, resistivity relation. Just I given you as a simple table. Is it clear, everyone? User quick reaction. So is it clear? That means is it an easy method to remember? It will help you in objective bits. Is it easy method? Yes, right? So remember like this, right? Make a table. Okay, so with the resistance, resistivity increases, conductivity decreases. With decrease in resistance, resistivity decreases, conductivity increases, right? So this is given information. So completely we discussed about resistivity and conductivity. how they are depending one on the other. Now I am trying to decide good conductor and a bad conductor. Right? So how do you decide? Conductor, conducting the energy. You got the meaning or confusion? Conductor meaning is what? Which conduct the energy. That is what electrical energy here. Electrical conductors. So which is best conductor? Having the conductivity more or resistivity more or resistance more? Which is best conductor? Among these three, I am asking you, conductivity more means best conductor, or resistivity is more for conductor, or resistance is more for conductor? Answer me. How do you decide which is best conductor? Based on which value? Based on resistance only, right? What you are learning here, look at. If resistance is more, resistivity is more. What about conductivity? What about conductivity? Tell me. Anyone? If resistance is more, resistivity is more, what about the conductivity for the same material? Is it more or less? Is conductivity is more or less in this case? What happened? Not answering. Are you following or not? No answer. So here simply conductivity decreases. Conductivity decreases. So once the conductivity decreases, it classified as bad conductor. Right? So here for the best conductors, what you require? Conductivity more, resistivity less, resistance also less. They are best conductors. Right? Resistivity less, resistance is less, and conductivity is more. So they are said to be here good conductors. Bad conductors, conductivity is less, resistivity is more, resistance also more. So this resistivity also called as specific resistance. Remember another name of this resistivity called as specific resistance. Right? So this is about conductors, good conductors, bad conductors. Right? So here in the table, table number 3, you are observing the values of specific temperature in ohm meters. So what the order is maintained in the table resistivity? Just give me your overall answer, speak out, observe the table and tell me what the order of resistivity. Speak out. If you don't know, go to quick reaction. Abhinay. No, not able to answer. Sricharan. Rohit. So no one is able to answer. Vikram, will you try? No?
Sir.
Yeah, answer. I asked the order of resistivity, increasing order or decreasing order?
So increasing order.
How do you decide decreasing order? What you observe?
No, sir, increasing order.
How you can decide that? Increase or decrease, whatever it may be your answer. How you are able to decide? What you can observe particularly here? Material name or material value? Value.
Sir, material value.
Value. Okay. Here they are given in 10 powers, right? So see the powers. First value is negative. Then last value is positive. So power value increased. So So automatically resistivity value increased. Then whatever it may be, it's a multiplier. Nothing, no importance to this one. First see the powers. They are in the increasing order. If the powers are same, then check the coefficient value here, multiplier value. Suppose among the silver and copper, 10 power minus 8, same. So what to do? Here you need to observe multiple value. So which is greater? That has resistivity is more. So among silver and copper, whose resistivity is more? Answer me. Whose resistivity is more? Which material has the highest resistivity among silver and copper? Why are you silent?
Copper, sir.
Copper. So how you said here, it has its multiplier 1.6. It is greater than comparing with the silver. Then see this, minus 8 only. So gold is greater, minus 8. It is aluminum, minus 8. It is calcium, minus 8. It is tungsten. It is minus 8. It is nickel. See, increasing. Right? Resistivity increasing. What happens to the conductivity if resistivity increased? Conductivity decrease or increase? With increase in resistivity value. I am in confusion. Are you following or not? Answer me. Resistivity increased. What about the conductivity? Decreasing or increasing? Answer me.
Decreasing.
Conductivity?
Decreasing.
Decreasing, falling down. So here, among all these materials, silver, copper, gold, aluminum, calcium, tungsten, towards last one, air, which is best conductor? Which is best conductor? Answer me. Which is best conductor? It is which has lowest resistivity, highest conductivity. Which is lowest resistivity here? The material which has lowest resistivity, is it the air or the silver? Air or the silver? It is silver, right? It has resistivity value lower and conductivity value is maximum. So how do you conduct conductivity value here? How do you find? Conductivity value is nothing, 1 by rho. So substitute 1 by 1.59 into 10 to the power of minus 8. That will give you here. That is equals to 1 by 5.9. So 1 by 1.6 take, then the power will become positive here. Suppose if you go for air, it is 1 by 1.3, that power comes to the numerator, becomes negative value here. So now compare these two values. Which is greater? This one, positive power, negative power always smaller. So like this, you can understand about the conductivity. Are you clear about this? How I got conductivity values here for the air and silver? Yes. So much information given in the table. Don't neglect this table, right? So you are deciding the material as best conductor or bad conductor depending on the resistivity values. Then you are deciding the conductivity value. Highest conductivity, lowest conductivity. Highest resistance, lowest resistance. Highest resistivity, lowest resistivity. Right? So based on that, you are able to decide them as here best conductors, bad conductors, and insulators. Right? Suppose in this water, suppose tungsten and silver. Which is best conductor, which is bad conductor? Tungsten is bad conductor, silver is best conductor. right? So like this, we can decide. Like this, we can decide here. Okay, so this help you to understand about the material nature towards electricity, right? So by knowing these resistivity values, you are using these materials as here conductors, semiconductors, and insulators. Conductors, semiconductors, and insulators. So that examples are given here, right? So germanium, silicon, these are used as semiconductors, right? Silver, copper, right? Silver, copper, and aluminum, we are using as here conductors, wires, in making of wires. These glass, rubber, right? Glass, rubber, we are using as insulators, right? These semiconductors are used as integrated circuits, ICs, chips in electronics, right? So that you need to study in this table, right? So this is about today's class in this evening session. We'll meet tomorrow.